Okay, so let's look at a few more examples then, and again, trying to become independent of our graphing calculator and being able to recognize the behavior of these polar functions. Just a quick reminder that this is a polar rose, and it has the characteristic equation because there's a coefficient in front of sine or cosine that's going to give us our petal length. So that would be in this case 5. There it is. The fact that there's a 3 here talks about our frequency. And we know we learned from the last example, and the same thing's going to be for this one, that if I do 90 divided by 3 to get 30 degrees, every 30 degrees, something is going to happen with this cosine function. It's either going to be at the highest amplitude, at the equilibrium mark, or at the lowest amplitude. Now, some students like to have that table of values for r's and thetas, and they know that since they found the 30-degree increment, that they can just list out every 30 degrees, and that's fine. And that might be how you start doing some of the homework, with this table of values. Some students can kind of see that table, know that 30-degree increment, and they can start graphing right away. Okay, so then now for cosine, because the cosine of 0 actually gives you 1. Remember, cosine started at its highest amplitude, so then we have 5. Again, just kind of associating that with just the normal cosine graph. Cosine would start at the highest amplitude, go to 0, go to the lowest value, go back to 0, and go to the highest value. So we're starting at the highest value. And then our next increment, 30. 30 times 3 is 90, and the cosine of 90 is back to 0. Then 60 degrees, our pattern would be -5, because 60 times 3 is 180. Cosine of 180 is -5. So again, we're going from the highest to 0 to the lowest, highest to 0 to the lowest. And then we go back to 0, we follow the pattern, the highest, back to 0, and then to the lowest. And so again, just following that pattern, now we're going to graph our function. Remember, I had asked for the start to put a star by it. So on the graph at 5, 0, which is, well, I'm going to kind of ignore, it almost looks like it counts by 2, but I'll count 1, 2, 3, 4, 5. So I'm going to put a star right there, so I know that that's where it begins. And then, I'll go to a thinner marker. There we go. And we have to get to 0, we have to basically get into the origin by 30 degrees. So I could either do this direction, or I could do this direction. And just like the last one, in every graph you're going to graph, it's always counterclockwise, because that's how you go around the unit circle. It's a counterclockwise direction. So I know that in this case it was the first time. So I need to get from here to the origin. And then I could also even look to my next one. At 60 degrees, go -5. So 60 degrees is this ray right here, but going -5 actually backtracks down in this direction. And so go 1, 2, 3, 4, 5. So I kind of like having 3 points at a time. I'm at the star. I need to get through the origin and end up there. So, maybe you can try to make that one continuous arc. Do your best like that, and we're going in that direction. So the first petal tip here would be 5, 0 degrees. This petal tip here is -5, 60. And again, thinking back, we were at the highest, we were at the equilibrium, and then we're at the lowest. So then I'm going to get back to the origin, and then I need to get to 5, 120. So it might be helpful to mark out where that is. 1, 2, 3, 4, 5, which is right there. So again, I need to go from, I'm going to switch colors here. I need to go from -560 to the origin and up there to 5, 120, kind of in one smooth arc if possible. So we're going up to there, drawing it in that counterclockwise direction. And then finally, I need to get back to the origin, and notice that -5, 180. So 180 is out to the left, but -5 coincides right back there. I should also label this point as 5, 120. And so we try to make one smooth, continuous arc through there. What am I going to ask for on an assessment? I'm definitely going to ask to star the start. right? So make sure you put a star there. I'm going to ask for arrows indicating the direction. And for a rose, I'm going to ask for you to label the petals in an appropriate fashion. So an appropriate fashion, this negative 560, that's appropriate. I don't want 5, 240 because that isn't the order that this is graphed in. Okay, now let's look at the next one, 5 sine of 2 theta. So now it's my first time where I have a 2 instead of a 3. I'm going to graph this by hand. So then what I'm thinking about is doing 90 divided by 2 to get my increment. So that's a 45-degree increment. So every 45 degrees, something's going to happen in terms of our sine function. So if you want to write a table of values, feel free. 0, 45 degrees, 90, 135, 180. Now, because it's even, I need to go all the way to 360 to see all the petals. So I have to go to 225, to 70, sorry, drew blank, 315, and then back to 360 degrees. Now, sine function, remember at the sine function, sine of 0 is 0. So we're starting at the equilibrium. So 0, I have a radius of 0. 45 degrees, so that's 45 times 2 is 90. I'm going to give the highest point, which is 5. Then back to 0. Then I'm at negative 5. Then I'm back to 0. Then I'm at 5, back to 0, negative 5, back to 0. Because sine of 0 is 0, we know we start at the origin. So put a little star there. And then, we have to get to 5, 45 degrees. So 1, 2, 3, 4, 5, and here's 45 degrees. So I'd label that point 5, 45 degrees, and I need to get there in a counterclockwise direction, which means I'm coming underneath it just like that. And we draw arrows. So, I think it's helpful to then realize I'm going to go back to 0, 90, but then I also need negative 5, 135. Well, 135 is the ray out here in quadrant 2, but negative, go backwards. 1, 2, 3, 4, 5. I'm right there. So that's the goal. That's my next spot, negative 5, 135 degrees. And again, thinking about, well, I'm at this point here. I have to get to the origin, and I've got to get here. Try to draw that in one continuous arc. And that arc sort of then determines how wide your petals are going to be. Draw your arrow through here. Okay. And then, we know we're back at 0, but then I got to get to 5, 225. Well, 225 is this ray down here in quadrant 3, and we go out 1, 2, 3, 4, 5. So maybe I'll switch to blue here. So this is 5, 225. And again, thinking about I need to get from here to here, and then back to here. Try to do that in one continuous arc. And then kind of comes on through here. And it's not going to be perfect, and that's okay. Right? We're just learning. We're just sketching here. And then our last curvature, I guess I'll maybe use yellow. And I want to go from 5, 225 to negative 5, 315. Well, 315 is down here, but negative 5 is back here, where we've kind of already graphed that. So 1, 2, 3, 4, 5, which is right there. So again, think about that curvature from here to the center and out. Is going to be that curvature right there, drawing arrows, and then certainly we can label that particular point. This was negative 5, 315. And then we just complete our circle, going through the origin again. So there are 4 petals, and I knew there would be 4 because 2 times 2 is 4. And again, notice the order that this is being graphed. It does not go in the order of the quadrants, right? If I think about how this is being graphed, it's going out to there and then following along to here. And that's the negative radius, then back to a positive radius, and then back to the negative radius. So order matters. So this is our first petal, this is our second petal, this is our third petal, and this is our last, our fourth petal. That I'm going to ask as we move forward. Okay, let's look at the next one together. Well, actually, maybe instead of, well, that's fine. We can at least figure out, and we'll talk about this one. But there'll be 8 petals to graph. And so how would I get those 8 petals? So if I think about that frequency of 4, so 90 divided by 4, that would be 22.5 degrees. So it's kind of an awkward value. Every 22.5 degrees, something would happen. The sine graph starts, right? The sine graph starts at the origin. And if I wanted to make a table of values, so r comma theta, I'd want to go every 22.5 degrees. So starting at 0, every 22.5 degrees would give me something different. Sine starts at the origin, so that's 0. At 22.5 degrees, we're at the maximum, which is 5. Another 22.5 degrees would be at 0. So, you could continue to do that, and I think maybe I'll just leave that as an exercise and maybe look at the next example together with you just to kind of solidify this. So it says, how many distinct petals will the following roses have? And so because this is 9 as an odd value, I know there's going to be 9 petals. Because 6 is even, I know there's going to be 12 petals, right? Now, when it says like list them out in order, so I kind of like this. This will kind of emphasize what we did in the last example without having to do too much graphing. So do 90 divided by 9. So every 10 degrees for this first one, something is going to happen in terms of our cosine graph. So 0, 10 degrees, 20 degrees, 30 degrees, 40 degrees, maybe by 50 degrees, we'll see what's happening. So cosine starts at the greatest amplitude. So cosine of 0 would be 1, and then 1 times 10 is 10. And then after cosine, like if we pick 10, we're going to go back to the origin because 10 times 9 is 90. Cosine of 90 is 0. 20, we get to negative 10. 30, we're back to 0. 40, we're at positive 10. 50, we're back to 0. And so I start to see a pattern that the petals come actually 20 degrees apart because that's 2 steps of 10. If I needed to list out all of the petals for this particular example, I could. The radius, so it'd be like 10, 0 degrees, then to be negative 10, 20 degrees, then to be positive 10, 40 degrees, and then it's negative 10, 60 degrees. And again, because I know it's double increments of 10, then it's positive 10, 80 degrees, and then it's negative 10, 100 degrees, then it's positive 10, 120 degrees, then it's negative 10, 140 degrees, and then it'd be positive 10, 160. Now, that's 9 petals. If I accidentally do one more petal and say negative 10, 180, because I'm just following the pattern, notice negative 10, 180 is the same as 10, 0. So I know that there would be 9 distinct petals. And then I won't do the second part, these 12 petals, but if like 90 divided by 6, that means every 15 degrees, I'd have something happening with my sine function. So, if you wanted to follow the pattern there, r comma theta. So, if my, again, thinking every 15 degrees, 45, 60. So we start seeing a pattern, 90. So sine of 0 starts at 0, and then we go out to the maximum amplitude of 12, then it's 0, then it's negative 12, then it's 0, then it's positive 12 again, then it's 0. So notice when do these have values? Starting at 15 degrees, and then 30 degrees later at 45, because that's 2 groups of 15. And then 30 degrees later at 75. So you could also write a pattern without having to do the whole label, and I'll just start with just a couple. So 12, 15 degrees, and then it'd be 12, 40, negative 12, my bad, negative 12, almost there. Oh, okay, so I erased everything, my bad. So 12, 15 degrees, and then negative 12, 45 degrees, then positive 12, 75 degrees, and then it would be negative 12, 105 degrees. And again, you're just adding 30 each time because 30 would represent 2 groups of 15. Okay. Last thing on this video, I know it's a lot, but I want to make sure that we have a good basis for these polar roses. So I see a polar rose here, and I see the star has been there. So since 0 degrees actually gave me an amplitude, that's telling me it's the cosine function. And it looks like it's 1, 2, 3, 4, 5, 6, 7, 8. So I know that it's going to be 8 cosine. And then count the petals. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We just kind of had that one. So because there's 12, that would have generated from a 6 theta. Now, the rose to the right is the exact same number of petals, has the exact same petal length, but notice where the star is. It's on the left. So if you think about when would cosine ever start with a negative radius, it would start with a negative radius if you had a negative 8 instead of a positive 8. So that star could sometimes start on the negative side if we have a negative value there. So I'm hoping that gives us a good, like I said, a good basis. And our goal by the end of this unit is to be able to graph and recognize polar functions without having to rely on our graphing calculator.